Okay, most frequently when I'm talking to young Earth creationists or anyone else of, frankly, any sort of opinion on the matter, usually makes a key misrepresentation of a couple words, and in fact, the entire method of science. So today I'd like to address the definition and the exact meaning of what this is. So the first thing I'd like to talk about is the scientific theory in and of itself. What is a theory? And what is a hypothesis? And what is the difference between the two? Now, in popular usage, a theory is just a vague and fuzzy sort of fact, and a hypothesis is often used as a fancy synonym for guess. But to a scientist, now, a theory is a conceptual framework that explains existing observations and predicts new ones. For example, suppose we see the sun rise. This is an existing observation which is explained by theory of gravity proposed by Newton. This theory, in addition to being explained why we see the sun cross the sky, also it explains many other phenomena, such as the path followed by the sun as it moves, as seen from Earth, across the sky, the phases of the moon, the phases of Venus, the tides, just to mention a few. You can today make a calculation and predict the position of the sun and the phases of the moon and Venus, the hour of maximum tide, all 200 years from now, for example. Now, a hypothesis, on the other hand, is essentially a working assumption. Typically, a scientist will devise a hypothesis and see if it holds water, per se, by testing it against available data obtained by previous experiments and observations. If the hypothesis does hold water, the scientist declares it to be a theory. Now, the process where we get from our general assumption or a hypothesis to a generally accepted scientific theory is through the scientific method. The scientific method is the best way yet discovered for winnowing the truth from lies and delusion. The simple version looks something like this. First, we make an observation, some aspect of the universe. Let's say, when I drop a ball, it will fall. Now, we're going to invent a tentative description called a hypothesis. That is consistent with what you have observed. I've dropped a ball, and in fact, it did hit the ground. So we're going to use this hypothesis to make predictions. If I drop a ball again, or in fact, let's say I drop an apple from a tree, it will hit the ground. It will not just float in thin air. Now, the next step is to test those predictions by experiments or further observations and modify the hypothesis in light of your results. So, let's say we observe an apple falling from a tree. It hits the ground. Or, in fact, as Isaac Newton very conveniently found out, it hit him in the head. Obviously, we know this is a little bit of a analogous story, per se, because we don't know if exactly even this, Now, we observed the apple falling from the tree, so we do many, many, many more experiments, and in fact, we control this by removing outside factors such as wind resistance, any sort of magnetic field. We make sure that, let's say, the ball that we're dropping is not magnetic, or the surface we're dropping it to is not magnetic, or it's not affected by the magnetic field outside, maybe the magnetic field of the Earth. So we're talking about the individual gravity. So we're going to repeat these steps of using the hypothesis to make predictions and continuing to test these predictions until there are no discrepancies between the theory and experiment and or observation. So what we have decided here is the theory of gravity. For example, if I drop a ball, it will hit the ground. It will go down towards the gravitational pull of the Earth. Now, when consistency is obtained, the hypothesis becomes a theory and provides a coherent set of propositions which explain a class of phenomena. A theory is then a framework within the observations are explained and predictions are made. So now we can use our theory of gravity to make predictions about future balls that we're dropping, or any other matter for that effect that would be pulled in with any sort of gravitational pull with the Earth. Now, one would find it interesting to say that this theory that we just came up with through this sort of experiment and observation is only a theory.